Okay, so this is the second part of radian and degree measure, and they ask us to summarize the range of angle measures in radians for each of these quadrants. So if we're in the first quadrant, so anywhere where we land in the first quadrant, our angle would need to be between 0 and pi over 2. Sorry, that's a less than. So anywhere from 0 to pi over 2 is going to land in the first quadrant. Anywhere from pi over 2 to pi is going to land in the second quadrant. Anywhere from pi to 3 pi over 2 is going to land in the third quadrant. And anywhere from 3 pi over 2 to pi, 2 pi is going to land in the fourth quadrant. If we were in degrees, we would just be going from 0 to 90, 90 to 180, 180 to 270, and 270 to 360. Again, be sure when you're using the degree symbol or when you're using degrees that you put the degree symbol down, because if you don't, it means it's measured in radians. So typically when we label angles, we often use theta, a Greek th, we use alpha, and we use beta. Okay, those are all just Greek letters. We're not going to worry about what they mean. It's just like using A, B, or C. We just use Greek letters often. In physics formulas, they have a tendency to use them for angles, so we're sticking with that. Okay, so this one says in the diagram at the right, draw the terminal side of an angle in quadrant 3. So that means just draw my terminal side somewhere over there. In standard position, I would have my initial side on the positive x-axis. It says to label the positive angle as alpha. So this guy right here would be the positive angle, turning counterclockwise. And alpha looks like that. I call it fish swimming left. Then we have to label the negative angle beta. So that would be spinning clockwise, and that one's beta. And since both of these guys start and end in the same place, we call them coterminal angles. All right, in these examples, they're asking us to find one positive and one negative angle that's coterminal with each of these. Technically, if we have this angle right here, 5 pi over 6, 5 pi over 6 would be somewhere over here in the second quadrant. There are infinitely many angles that are coterminal with 5 pi over 6 because we can keep turning around and round clockwise or counterclockwise and getting ones that land in the same spot. But they wanted us to find a positive angle that's coterminal with 5 pi over 6. So if we started out and we spun all the way around and then we went 5 pi over 6, we would land in the same place. So to do that, we're going to add a 2 pi, or one revolution of spinning all the way around. So if I'm going to do 5 pi over 6 plus 2 pi, I have to get a common denominator of 12 pi over 6. So 5 pi plus 12 pi is 17 pi over 6, which is the green angle that I drew up there. That's a positive angle because I spun counterclockwise. If I wanted to do a negative angle that was coterminal, I just start out and go the opposite way. So to go the opposite way, I want to subtract pi over 2. So if I start with 5 pi over 6 and I subtract 2 pi, again I have 12 sixths. So 5 sixths minus 12 sixths is negative 7 sixths, and that one again is a negative angle. Okay, so if we want to find coterminal angles, we're going to add or subtract 2 pi to our theta, and that will give us coterminal. Because 2 pi is a full rotation, so it would start and stop in the same spot. If I'm in degrees, I'm just going to add or subtract 360, and that's going to put me in the same spot. So go ahead and pause the video while you guys try a B and C. All right, so on B, I added 2 pi, so I changed it to 8 pi over 4. And then negative 3/4 plus 8/4 is 5/4. That's positive, so I know it's a good answer. For the negative, I can subtract 2 pi, so I'm going to subtract 8/4. Negative 3/4 minus 8/4 is negative 11/4 pi. So again, they said make sure you have a positive and a negative. These aren't the only two answers. You could have added 2 pi again and again, or subtracted 2 pi again and again, and they would have given you more. Okay. On C, when I add 2 pi, I'm adding 6 pi over 3. If I add, it gives me 17 pi over 3, which is a positive answer. If you subtracted 2 pi, it gives you negative 5 pi over 3. That's still positive, so you could have given this answer as your positive answer also, because it's still positive. In order to get it negative, you actually have to subtract 2 pi again to get negative pi over 3. Okay, we cannot just throw a negative out in front and call it negative. You have to keep subtracting 2 pi until you get a negative answer. All right, so we don't typically want to convert. We want to work in whatever units they give us. So if the problem is stated in degrees, we'll work in degrees. If it's stated in radians, we'll work in radians. But we need to be able to convert from one unit to another, just like you can convert between feet and meters and that sort of stuff. So when we converted in math or in science class, what we like to do is multiply by 1 in a useful form. So since on a circle, pi and 180 degrees are at the same spot, if I put pi radians over 180 degrees, that's equal to 1. Or if I put 180 degrees over pi radians, that's also equal to 1. So what you want to do when you convert is just use whatever fraction that when you multiply by is going to allow you to reduce out what you want. So if you have degrees, how you usually did this in science class is if you had something with degrees, you'd put degrees on the bottom and radians on the top so that your degrees would reduce out and your answer would be in radians. Okay. Likewise, if you start out and you have radians on the top and you multiply by degrees over radians, then your radians would cancel out and your answer would be in degrees. So what you want at the top of your ratio and what you start with goes on the bottom of your ratio, and that way you can reduce it out. Here we're going to convert from whatever unit we have into the other one. So on A, we're starting out with 75 degrees. When I'm choosing my 1 in a useful form, if I want to get rid of degrees, I need to put degrees on the bottom. So my 180 goes on the bottom, and my pi goes up on the top. When I do that, then I can reduce out my degrees, and my answer is just going to be radians. I don't usually write radian when it's radian. So right now I've got 75 pi 180. If I'm trying to reduce without a calculator, I don't usually notice the biggest thing that goes in. Like I can right now 5 is going to go in both the top and the bottom. So let's see, 5 goes into 180 36 times. And 5 goes into 5 15 times. Then I happen to notice that both 15 and 36 are also divisible by 3. So 3 goes into 15 5 times. 3 goes into 36 12 times. And my final answer is 5 pi over 12. Okay. I'm going to go down to D now so that we can do 1 in radians. So if we started with radians, come on, pen. If we started with radians, we would be starting with the 5 pi over 3. Sorry, my pen's locked up, which means I have to hit the pause. Okay, sorry about my pen locking up. So right here with the 5 pi over 3, that was in radians. So I needed to put my pi radians on the bottom and my 180 degrees on the top. When I do that, the radians would reduce out. The pi's would reduce out. I can also reduce how many times does 3 go into 180? That's 60. And then 5 times 60 equals 300. So you can pause the video while you try these other 4 and then see how you do. Let me know if you have any questions in class.